सो हेलो स्टूडेंट्स। तो चलिए आज शुरू करते हैं। इलेक्ट्रिक पोटेंशियल का जो बाकी का टॉपिक्स था उसको आज ख़त्म करेंगे। कुछ नॉट नॉट ऑल टॉपिक्स, स्टिल सम टॉपिक्स रिमेन, बट वी विल ट्राई टू cut off today's topic as soon as possible. But before that, starting the topic for electric potential, I had mentioned that in order to get things in electrostatics, you need to find two things. Okay, one is electric field and other is electric potential. Okay, one is electric field E and the other is potential V. So E is a vector quantity whereas V is a scalar quantity. Okay, in electrostatics, either of these things can help you get into the root of the problem. You can solve the problem easily. Okay, if either of these things are available to you, that means you can solve electrostatics using this concept, or you can solve electrostatics any problem using the concept of electric potential. Okay, that means there must be a relationship between these two things. There must be a relationship between these two things, but it is a vector quantity and it is a scalar quantity. Then how they are related to each other? As I had previously mentioned, that electric field E is a very special vector. Why it was special? I had also given you the reasons, because its curl is 0. Its curl is 0. For electrostatic field, the electric field intensity, the curl of electric field intensity is 0. I had given you the concept of curl in the previous class. So it is not necessary to remember right now, but it will be important in the later classes. But in those classes, you shall be taught again for these things. Okay. Since the curl of electric field vector is 0, of any vector is 0, then it should be equal to the gradient of some scalar function. It should be equal to the gradient of some scalar function. The same thing. Okay, it is the del operator, it is also the del operator, the same thing. But curl means the del operator and is operated with a cross product with electric field E, and this thing is directly operated over a given scalar function. So in this case, electric field, the gradient of that scalar function, whose gradient is equal to electric field E, that scalar function is your potential V. That scalar function is your potential V. Okay, so we are going to derive how are we going to state the relationship between E and V, or if E is given, then how are you going to find V, or if V is given or the function V is given, then how are you going to find E, or the interdependence between E and V. Okay, so today's topic is relationship between relationship between E and V. Okay, relationship between E and V. So similarly, just recall the concept of electric potential, how we derive electric potential. Similarly, let us place a charge Q at origin. It is O, and this is your line of action. It extends up to infinity. Let B and A be those points. B और A दो पॉइंट्स है, इसका पोटेंशियल होता है VB, इसका पोटेंशियल होता है VA. ओके, लेट द डिस्टेंस बी dr. इनके बीच जो डिस्टेंस है उसको आप डिनोट कीजिए dr से, स्मॉल डिस्टेंस. ओके, दैट मींस दे आर वेरी क्लोज टू ईच अदर. If Q is a charge, then it should have an electric field in these regions. Okay, it should have an electric field, and points A and B are in these regions. So now it has an electric field at this point and electric field at this point. They may be different. Okay, now just write down into those statements. Let us consider a charge Q is at origin O. This is your origin. A and B are two linear points. Okay, are two linear points. Why are we considering linear points? Because it is easy for us to derive to a conclusion. A and B are two linear points. Linear points, they are situated in the same line along this line of action. Two linear points in its electric field. In the electric field of Q, A and B are two points. Okay. So आप ये देख के बता सकते हैं क्या? कैन यू टेल मी फ्रॉम द पिक्चर वी ए इज ग्रेटर और वी बी इज ग्रेटर? सो यू कैन एक्चुअली से that VB is greater than VA. VB from the picture point of view, VB is greater than VA. Okay. So as you know that V is inversely proportional to the distance. The closer the distance, the greater the potential. The larger the distance, the smaller is the potential. So in this case, VA is greater than V. So if you give this point A, the potential at point A be V, okay, it is V, then for a small distance, from a small distance, this position has a potential V plus dV. Okay, this position has a potential V plus dV for a small distance. If they are infinitesimally distance apart, then the change in potential is also infinitesimally small. So we are denoting it as V and the other point as V plus dV, where dV is the infinitesimal change in voltage. So what is the measurement of dr? Dr, why or what should be the dimension of dr? Dimension means the length of dr. That means it should be so small. It should be so small. So you can see that, okay, I am coming to that point. If the electric field at this point is EB, then the electric field at this point is EA. Okay. So they are two different quantities. But we are going to consider dr so small that EB is equal to EA. We are going to consider dr so small that EB is equal to EA. There is the electric field in that region is almost constant. Okay, the electric field in that region is almost constant. So in this region the electric field is E. Okay, in this region the electric field is E. Now we are going to bring in Q naught. Okay, these are not required now. We are going to bring in Q naught. Q naught is placed at point A. We are going to bring Q naught to B. That means Q naught is going to travel a distance dr. Q naught is going to travel a distance dr. Force is acting on this direction. Force is acting on this direction because these are two positive charges. They repel each other. This thing is repelling this unit positive test charge. But the condition is that the Q naught, the unit positive test charge, must be so small that it should not disturb the configuration of our source charge. Okay. So now in its electric field, A and B are infinitesimal distance apart, which is dr. Okay, which is dr. Now you can actually calculate the work done. As you can see from this point, work done is equal to minus FDR. Why minus FDR? As you know that work done is F dot dr. This is cos theta. FDR is equal to FDR cos theta, as I have mentioned earlier. So the direction of dr and f, what is the angle between them? The angle between them is 180 degrees. So cos 180 degree is equal to minus 1. That's why F dot dr, I am writing directly FDR. Okay, I am writing directly FDR. This is our work done. You can write it as dW. dW is equal to minus of FDR. And what is this force equal to? What is this force equal to? If electric field is constant at this region, then it should be denoted by E. It should be denoted by E. So F is equal to Q naught E. F is equal to Q naught E. The force on this charge at this point on E or in this region is Q naught E. So you can actually replace these things. So dW is equal to minus Q naught E dr. This is your required equation. Okay, this is your required equation. Now we are going to find work throughout another method. We are going to find work throughout another method. What is that another method? As you know that electric potential, the difference of this electric potential, okay, VB minus VA is equal to work done by that charge. As you know from the, as we know, continue from this side, as we know VA, the difference in this potential is equal to work done by charge. Work done in bringing that charge from Q, from A to B against these field directions. Okay, against these field directions. So that must be, so what is the difference in this potential? VB, or the point B, at the point B, the potential is V plus dV, and the potential at A is V. What is work done? Let that work done be dW, because the small amount of work done, and it is Q naught. Okay, so now then see, you can see that V and V are getting cancelled. dV is equal to dW by Q naught. And from this point, you can actually see that dW is equal to Q naught dV. Q naught dV. This is your equation 2. You can name it equation 2. Let me check you are actually seeing this or not. Now you can see that if it is work done, then it is also work done. Okay, if it is work done, then it is also work done. That means equation 1 and 2 are same. The left hand side of equation 1 and the left hand side of equation 2 are similar or equal. That means the right hand sides also must be also equal. So comparing equation 1 and 2, you can derive to the formula, or you can reach to the conclusion that Q naught E dr is equal to Q naught dV. You can actually conclude at this point. So what is your E? E is equal to, see, the Q naught are getting cancelled, minus dV upon dr. This is your required equation. This is your required equation. When you are rearranging these things, you will see that E is equal to minus dV upon dr. And this thing was, I was telling to you that this is equal to the gradient. This is equal to the gradient. This thing is known as the negative gradient of potential. So we can write E, electric field E, is equal to the negative gradient of potential. So if you are done with the upper thing, so we can rub them off. So what is electric field? Electric field is equal to negative, you can write directly like this, negative gradient of potential. Negative gradient of potential at that point. What is the value of electric field? It is equal to the negative gradient of potential. That means electric field Okay, this is actually good, visible to you. So we can see that E is equal to minus dv upon dr if v is given a function. If v is given a function, you can actually differentiate it, post a negative sign in front of it, and this is what? This is equal to your electric field at that point. If you have any points, you can also put those points in this equation and you will find the value of electric field actually. So electric field E is the negative gradient of potential at that point. So you can see that they are how much interrelated to each other. So since electric field is a vector quantity for a given system of charges, it is very hard, or it is very not hard, it is very difficult to find all the electric field vectors and then count and then make their vector sum, calculate their vector sum, and then finally reach the conclusion. But which is a very, which will take a lot of time. But in case of electric potential V, you can directly calculate the potential and you can add them algebraically. So it is easy to calculate V and then find out the net potential after that, and after that you can actually find electric field E. From this point, okay, from this point you can see that dV is equal to minus E dr. dV equal to minus E dr. And now if you integrate it, you will find that V is equal to minus E dot dr along a line, if it is a closed integral. Okay, why this is it a called closed integral? It will require more than one or two classes to give you a better concept. Okay, but until then you just memorize this formula, E equal to minus dV upon dr, and then if V is given to you, you can also, or E is given to you, you can also find the potential. Okay, you can also find the potential. So electric field E is when you differentiate V with respect to what you get electric field, and B is when you integrate electric field along the line. Okay, so this is what about today's class. So we are yet to derive some conclusion from this point or from these things. So what are those conclusions? Let me derive those conclusions. You can see that E and what is the relation between these things? That means gradient of B means changing of B with respect to some distance. At this point, what is B, and at this point, what is B? If it is V1, it is V2, and at this point, this is separated by distance S. Then, what is the rate of change of V with respect to distance? That will give you V2 minus V1 by S. This is what is about our gradient. The change in that quantity with respect to distance, that is called our gradient. Okay. So you can see that E is equal to the negative of that gradient. E is equal to the negative of that gradient. That means when it decreases, E increases. When it increases, E decreases. Okay. So let us write down those things into statements. So what does those things say? Let us write that. So it is actually equal to the magnitude. Okay, dV by dr is equal to the magnitude. If you want to calculate the magnitude only, you can actually write E is equal to dV upon dr. But this negative thing gives you the direction of electric field. This negative thing gives you the direction of electric field. Okay. So nothing to worry about. If you have any problems, you can directly write in the comments, and I have given my contact details there. You can contact me for any numericals thing regarding these concepts, and like our video, support us, subscribe to our channel, and share it with your friends. Up until then, take care, practice more. Okay, see you. Thank you all.